Hello everybody and welcome back to another video where we go over some example questions for your IGCSE Extended Mathematics classes. And let's just begin with a pretty simple matrix multiplication question. Again, these questions are entirely based on your knowledge of the matrix multiplication algorithm. So let's just continue. So m squared, So m squared is going to be equal to the matrix 1, negative 3, negative 4, 2 times 1, negative 3, negative 4, 2. And this right here is going to be a 2 by 2 matrix. I'm going to write like this. And the first column of this 2 by 2 matrix is going to be 1 times this column minus 3 times this column. So that's going to be 1 minus 3, 1 minus 3, and then negative plus negative 3 times negative 4, which is 12, and plus negative 3 times 2, which is negative 6. The second column is going to be the second column of the second matrix. So it's going to be negative 4 times this first column. So that will be negative 4 plus 12. And then plus 2 times this second column. So that's going to be negative 4 minus 8. And 2 times 2, so plus 4. So our answer is going to be the coefficients or the numbers are going to be 13, negative 9, negative 12, and 16. Let's also solve this question right here. Again, this is going to be 4. I'll write it with red. It's going to be 4 plus 5 times 3, so 15. Is equal to 12, and also 5 times 2, so 10, 4 times 2, so 8, and then plus 5 times minus 1, so 8 minus 5, which is equal to 6b. And if you solve these, you get, what do you get? Oh wait, hold on, I'm very sorry, this value is not 12, it's 18. Yeah, right. So we get 4a is equal to 3, and hence a is equal to 3 by 4. And similarly, b is going to be equal to 3 over 6, or just 1/2. Right. Alright everybody, now let us continue on with this statistics question. And here we are given a stem and leaf diagram. And if you want a quick revision, a stem and leaf diagram is just another weird method to represent data. And basically what it does is that all of these numbers here, these are called the leaves, show the units digits of all the values in our data. And all of these values, which are the keys, show every other digit of the values in our data. And this key right here represents how you can read the diagram. So here our values would be 0, 5, or just 5, 7, 8, 9, 11, 14, 16, 17, 18, 18, 19, 23, 25, 29, and finally 32. And what it wants us to do here is that it wants us to draw a box plot. Now remember, for a box plot we need the minimum, the lower quartile, the median, the upper quartile, and the maximum. And we're gonna have to find all of these values from the stem and leaf diagram. So how do we do this? Well, the minimum value is going to be the first value in our list, so that's just going to be 5. So let's draw our first line at 5, like this. And now the rest are a bit more complicated. We have 15 data values here, which means that we can just use the formulas if you want a quick way, or you can I don't know, you can figure it out like in your head which values are the lower quartile, the median, and the upper quartile. But I'm just going to use the formulas. So the lower quartile is going to be this plus 1 divided by 4. So our lower quartile is going to be the fourth value. Our median is going to be this plus 1 divided by 2, so the eighth value. And our upper quartile is going to be this multiplied by 3, so the 12th value. Alright, so what is the fourth value? Well, the fourth value is, this is 1, 2, 3, 4. So the fourth value is 9. So this right here is going to be our, not that, this right here is going to be our lower quartile, because this is 0.9. Alright, the eighth value is, so this is the fourth, this is the fifth, sixth, seventh, eighth value. Wait, no. Yes, so this is the eighth value, and this value is 17. So our median is 17. So let's just write that here as well. I'm gonna write these in here. So our median is 17, and 17 is this point, should be this right here, because this point is 17. Right. Our eighth value is going to be, so 17 was the eighth value, the 12th value. So this is the 9th, 10th, 11th, and 12th value is going to be this, which is going to be 23. So 23 is going to be right here. Right. And finally, the maximum value is just going to be the final value, which is 32. So we can put that here like this. And now we just fill in the gaps and complete our box plots. And that should be our answer. Alright everyone, here we have a decent trigonometry question. And remember, in your trigonometry questions, you have to remember the law of sines and the law of cosines. And for here, this is a law of sines question because well, you know one side, and you know its corresponding angle, and you know another side, and you want to figure out its corresponding angle. So remember our sine rule. Sine rule says that 16 divided by the sine of 124 degrees is going to be equal to 7 divided by the sine of x. So now we just have to solve for x. So sine of x is equal to, what is it equal to? It's going to be equal to 7 multiplied by sine of 124 degrees over 16. And so x is just going to be the inverse sine of this expression. I'm just going to write it here. There we go. And what we can calculate the value of this by just plugging it into our calculator. So the inverse sine of 7 times the sine of 124 all divided by 16 is going to equal it's going to equal 21.3 degrees to 3 sec feet, of course. Now remember, always be careful with your inverse sines, because remember 180 minus this angle. So what would that be like? It would be 159 degrees would also be a valid value for x, but not in this question. And the reason for that is that you can't have two obtuse angles in a triangle. So our only solution is going to be 21.3 degrees, which is going to be our answer. Alright everyone, here we have a really good geometry question that's going to involve a lot of calculations. So we are given a circular sector and a triangle, and it wants us to calculate the total area of this entire shape. So first of all, we can easily calculate the area of this rectangular region. That's just our triangular region. That's just 8 times 5 over 2, which is 20. And to calculate So to calculate the area of this circular sector, we're going to need to know a couple things. First of all, we're going to need to know the radius. And to find the radius, we already know this side, right? We can use that, figure that out using the Pythagorean theorem. So I'm just going to call that value r. The r is going to be the square root of 5 squared, so 25 plus 64. So that's going to be the square root of 89. Alright. We also need to know what this angle right here is, and that angle is just going to be 180 minus this angle, which I'm going to call alpha, where alpha, and notice that how the tangent of alpha is going to be the opposite over the adjacent, so it's going to be 8 over 5, or the rise over run, whatever you prefer, meaning that alpha is going to be the inverse tangent of 8 over 5. So we can calculate 180 minus alpha using our calculator quickly. So that's going to be 180 minus, what is it, inverse tangent of 8 over 5, and that is 122.005, let's just say. And I'm leaving more significant figures because we're going to do calculations with it. Now our total area now is going to be pi multiplied by root 89 squared, so that's just 89. Yes, root 89, so multiplied by 120.005 divided by 360 degrees, because that would be the proportion of the circle with this angle. So that's how we would calculate the area of this sector right here. And the rest of the area we already calculated as 20, so we can just add 20 to that, and our answer is going to be, what is it going to be? It's going to be pi multiplied by 89 multiplied by 122.005 divided by 360, and that plus 20. That gives us a value of approximately something 114.75. I'm just going to round that up to 3 sig fig, which is going to be 150. So that will be our answer. Alright everyone. Alright everyone, now let us continue on with this quadratic sequence question. Now there are multiple ways to solve these kind of questions. I'm going to show 2 of them here. So firstly, I'm just gonna write down all the equations and solve them. So I'm going to say that our sequence AN is some value a n squared plus bn plus c, and a sequence starts from n equals 1. So our n values are going to be 1, 2, and 3, and 4. Now we just need to choose any 3 of these values and plug them in to our sequence, and we will acquire 3 equations from that, which we can solve. So here I'm gonna plug in these the first 3 values of n. So that would give us the equation, first plugging in n equals 1 would give us the equation a plus b plus c is equal to our value of 3. I'm gonna do the same for n equals 2. So plugging in n equals 2, we get 4a plus 2b plus c is equal to 10. I'm going to do the same for n equals 3, which would give me 9a plus 3b plus c is equal to 21. Now we can solve these equations, and I'm going to do them using elimination. So firstly, I'm going to subtract this equation from this equation, and I am doing that to cancel out the c's. So if we do that, we would get 3a, so 4a minus a, plus 2b minus b, so b, plus c minus c, which is 0, which is equal to 7. I'm going to also subtract this equation from this equation, which would give me 9a minus 4a, so 5a, plus 3b minus 2b, so plus b, and c minus c equals 0. Is equal to 11. And now I'm gonna subtract this equation from this equation, and that would cancel out the b's to give me that 2a is equal to 4. So our value of a is equal to 2, and if we know our value of a, we can just plug it into one of these equations, and we will see that our value of b is equal to 1. And we know that a plus b plus c must be equal to 3. So here we see that c then is equal to 0. So our general equation, an, is going to be a, so 2n squared plus n and plus 0. So that's it. Now, there is another way you can solve this question that is accepted in the mark scheme, and it is a lot easier than doing all of this. So, and what you need to consider is basically when you're asked a quadratic sequence, you need to consider the second differences between the terms. Now, what I mean by that, basically the difference between the first and the second 2 terms, the second term is 7. The distance between the 10th and 21st term, or the first and the second and the third term, so 10, 21, and 10, is 11. And the same goes for here, which is 15. Now, this right here is what we call the first difference of elements of a sequence. And the second difference is just the difference between the differences. So our second difference here is 4. And our second difference here is also 4. And if you continue on with the sequence, you will notice that the second differences for a quadratic sequence are always constant. And in fact, for a quadratic sequence an, that's going to be an squared plus bn plus c. The value of the second difference between 2 differences is always equal to 2a, the value of 2a. And since we know that our second difference is 4, and you have to mention the term second difference in your answer, we can see that the value of a is equal to 2. And now you only have an equation that has 2 unknown variables, and you only need to solve 2 equations, which is going to make your work a lot simpler. Alright everyone, here we have a really simple differentiation question, and I just want to solve it because differentiation is a fun topic. So it asks us to find the gradient of the tangent to this curve right here at x equals 7. remember to find the gradient of the tangent, just take the derivative of our function. So here we just need to find y prime, which is we can find using the power rule. So this is going to be the 2 times the derivative of x cubed, which is the derivative of x cubed is 3x squared. So 2 times that is 6x squared, plus the derivative of x, which we know is 1. And we just need to plug in x equals 7 to this. And that would be 6 times 7 squared plus 1. And I'm just going to put that into my calculator. So that would be 6 times 7 plus 1, which is 295. Again, very simple question, but still a nice one. Alright everyone, here we have a transformation question, and these kind of questions are pretty important, so remember to study them. And it asks us to just describe the transformation that maps A to B. Alright, so remember your types of transformations. There are translations, rotations, reflections, and enlargements. Now, rotations, translations, and reflections do not change lengths and sizes. But here, notice how this shape has been diminished. So we know our transformation is an enlargement. So let's just write that. Of course, that is not going to be all of our answer, because for an enlargement, I might have written that wrong, I don't know. For an enlargement, we have to specify the scale factor and the center of enlargement, which is what our 3 marks are going to come from. One is from identifying the type of transformation, one from the center of enlargement, and one from the scale factor. So remember to find your center of enlargement. Mark all the important points on your shape. So I'm gonna say this is A, this is B, this is C, and this is D. Of course, the shapes are also named that, but whatever. So our point A right here is going to get mapped to this point. So I'm going to call that A prime, or A dash, whatever. And this point B right here is going to be get mapped to here. So that's B dash. C right here is going to get mapped to this point. So C dash. And D right here is going to get mapped to D dash. And remember, in an enlargement, you have to draw the lines between the corresponding points. So here, I'm going to draw the line between D and this D. So that's going to be this. And notice how the line between B and B prime is also the exact same line. So I'm just going to not draw that. I'm going to draw the line between A and A dash. And of course, remember to do this with a ruler or by counting the squares. And I'm also going to draw the lines between C and C dash. You technically don't need to do this, as you only need 2 lines. But I'm still going to do it. And now, notice how all of these lines intersect at this point right here. That is the point -1, -2, and this point right here is our center of enlargement. Alright, and the next thing we need to find is the scale factor. Now our initial shape right here is 3, it has this side length is 3, and in our output shape, the length of the corresponding side is going to be the length of this right here, which we see is 1. So our transformation essentially multiplies our length by 1/3. So our scale factor is going to be 1/3, right? Well, not actually, because notice how this right here is our center of enlargement, and our shape gets transformed to the other side of the center of enlargement. And remember that when that happens, the scale factor is negative. So our scale factor here is -1/3. And the reason for this is that, well, if it was positive 1/3, well, there would then be two shapes that would have a scale factor of 1/3, because if you just took like the symmetry if you just reflected this shape across this point, it would get like something like this, and it would be the exact same transformation, right? That you could not distinguish between these two. So in order to distinguish between those two shapes, we specify that it has a negative scale factor. So this is an enlargement. We say scale factor of negative 1/3, and a center of -1, so negative here, and that should get you all your marks.